Hello everyone, my name is Ankit Agrawal, and in this video we'll be looking into a very futuristic technology, that is brain-computer interface. So let's start. Let's talk about the flow of the video. First we'll be introducing about the BCI, then we'll talk about the brain and its complexity and what we need to know before we understand BCI. Then we'll look ahead into BCI techniques. How do we implement those? What are the current scenario until where we have reached invasive, non-invasive methods, and many more such things. Then we'll look into the potential of this technology and what scope of areas and domains it can cover. Lastly, we'll also look into a bit about concerns, ethical and moral issues that it can face as a new tech. So what is BCI? Brain Computer Interface. A BCI is a system that determines the functional intent, the desire to change, move, control, or interact with something in your environment directly from your brain activity. Like you don't have to control any replication device, you just have to think or only use your mind. So BCI bypasses the middle step of coordinating and using muscles to execute any desired action. Uh, Moving ahead, let's take an example of turning on a lamp. Uh, in motor control and BCI control, the first step is you have to plan. That is, you have to think in your mind and decide to turn on the lamp. There is a difference in the second step. In motor control, you move your muscles, you go ahead and click on the button to switch on the lamp, which as a result of which the lamp responds by turning on. Whereas in BCI control, you just have to think, and the second step onwards is handled by the computer. The computer analyzes your brain activity and identifies what you wish to do. And as a result, it sends the signal to the lamp instructing it to turn on, and which to the lamp responds and it gets turned on. So yeah, this is the basic difference between what a motor control process and what a BCI control process has. A BCI control process just skips the part of the motor actions which a body performs. Moving ahead. So there are three main steps or attributes of a BCI. First, we need a device to measure or record the brain activity. It can be an invasive, non-invasive, which we'll look into later in this video. Then we will need a computer that processes and analyzes the recorded data that is collected from the brain using those devices. Then third, we have an application or a device that is to be controlled. There's also an important aspect, that is feedback. A feedback needs to be provided to the user to indicate if their action was successful or not. Moving ahead. This is a very beautiful quote of David Eagleman. If our brains were simple enough to be understood, we wouldn't be smart enough to understand them. You can wait for a minute and listen to this quote in your mind. So our brain is made of approximately 1 billion neurons. There are 1 million billion connections, and there's about 1 quadrillion of events going on in our brain per second. So uh, these neurons work together in large networks to coordinate and control processes in your body, like from understanding what you see, hear, smell, taste, and feel, and even to executing movements, regulating your breath, heart rate, metabolism, any such thing. Neurons communicate using electrochemical signals. When a neuron is activated, it generates an electric signal that is then transferred to the next neuron in the network, which will transfer it to the next, and so on. A simple neuron does not generate enough electrical activity, but a collection of these neurons can generate an enough electrical activity that can be detected from the outside of the brain in case of invasive, non-invasive techniques, or even we can get into invasive techniques which detects at the neuron level, and we'll talk about this more in the later video. Moving ahead, so this process of detecting or recording the activity of the brain is called neuroimaging techniques. Neuroimaging techniques can be broadly classified into two types. There is electrophysiological neuroimaging and there is metabolic neuroimaging. Electrophysiological neuroimaging is directly measuring the electrical activity of the brain. But whereas metabolic neuroimaging, we are indirectly measuring the activity of the brain, like using blood O2 levels, radioactive emissions, such other stuffs. In electrophysiological neuroimaging, we use EEG, that is electroencephalography, MEG, magnetoencephalography, and in metabolic neuroimaging, we use things like fMRI. fMRI stands for functional magnetic resonance imaging, and PET. PET stands for positron emission topography. fMRI basically records the magnetic movements and PET records the radioactive emissions. Moving ahead, what is the difference when we talk about these two techniques, that is electrophysiological and metabolic? In electrophysiological neuroimaging, there is better temporal resolution and worse spatial resolution as compared to metabolic neuroimaging. And when we talk about metabolic neuroimaging, it's just the reverse. Like, it has worse temporal resolution, but it has good spatial resolution. And let me explain you what is temporal and spatial resolution. Temporal resolution is precision in recording events in relation to the time, and spatial resolution is precision in recording events in relation to the space of the place where the event occurred. So if you think of this, both are very much important. You can think of application in medical science. Both temporal resolution and spatial resolution is important. So we can use both in a mixed way, that is electrophysiological neuroimaging and metabolic neuroimaging, to get the best results. Moving ahead, let's come back to BCI. BCI can be implemented in two methods. There is an invasive BCI and there is a non-invasive BCI. I have mentioned these terms earlier in the video also twice, and now you'll get to know what I was talking about. Invasive BCI involves the surgical implantation of the device into the skull, and in non-invasive, it can work without the intrusive procedures into the brain. It can be just placed in the scalp. So EEG is an example of that, where you put an external device onto your scalp. And in invasive, we have examples like ECOG, where you put a device on your brain surface and there's microelectrodes which you put inside the brain. We'll talk about this in more brief in the next slides. Well, we already know what an EEG is. That's how Iron Man used to control his suit, right? So let's see what it actually is. So this is a guy, this is a very laboratory kind of EEG, where a man, you can see this image, the man connected to electrodes of an EEG, and there's a device that is available in the market. This is a EEG headset to measure electrical brain activity. This particular device is Emotive Epoch X. Moving ahead, sorry, just yeah. So this is what an typical EEG recordings look like. When you are in alert state, you will get beta waves. Alpha waves relate to relaxed state, and delta waves relate to deep sleep or very high relaxed state. So yeah, these, and there are many more that can relate to lust, that can relate to concentration. So yeah, these are the three basic waves, that's beta waves, alpha waves, and delta waves. Moving ahead, uh, so second is ECOG, electrocorticography. We already discussed that this is an invasive technique. You have to surgically open the skull and place the in electrodes on the top of your brain. So it is intracranial electrode grid for electrocorticography. It records electrical activity from the cerebral cortex. The electrodes are placed on the sensory areas and the motor areas of the brain. Moving ahead, we also discussed microelectrodes. Microelectrodes are very small devices. You can see this in the image. These are placed inside the brain. This is again an invasive technique. It can be used for stimulating as well as recording. On the right side of the screen, you will see a graph that gives a typical microelectrode recording. Now we have seen three techniques. Now we'll see ki after getting this recording, how do we move ahead? So what is the process of processing and analyzing the data that we recorded or detected in this BCI method? So in this image, you see EEG acquisition, but this is not specific to EEG acquisition. You can consider it for any common scenario that you got from any common method. So after you get the data recorded, the process of BCI is generally over. It's about now machine learning and artificial intelligence. How good you make a model, how good you train a model to detect what your brain is thinking, or to understand, analyze what your brain is thinking. So now it's about the model that you build, you do what feature extraction you do, your training and testing method. How do you classify, or if it is a regression related, it's regression or classify. It depends on the scenario. So let's not get into detail of that. That's quite in the domain of machine learning and artificial intelligence. Moving ahead, till now we have discussed about recording from the brain. What about writing to brain? Well, we are not here yet. The scene you can recall from the Matrix movie. We are not there yet, but we still have something to show. I will discuss it in the next few slides. TMS. It stands for Transcranial Magnetic Stimulation. You provide an external electric current which in place induces a magnetic field which induces an electric current inside the brain which creates which is in place of the natural electric current that would have induced. So it results into some motor or physical activity taking place. So if we can do this, if we can write to brain and if we can read to brain, then we can do brain to brain communication also. So what you are seeing on my screen right now is a communication between a sender and receiver. I'll explain. This is an experiment going on in a lab of BCI in a university. So the sender can see the game. He wants to hit a he wants to hit an object, but he can only see it. He cannot control it. And there's a receiver sitting in the other room. He cannot see what's going on the screen, but he has the keyboard that can control that game. So what is technically is happening is the data has been recorded from the sender's brain. It's being decoded using EEG. It's being transferred over the internet, and then it's being encoded again in the form of neural encoding using TMS. And the receiver hands are moving without his control. Like he is not controlling how his hands are going to move. It is being controlled by the sender who is thinking. So we are it's pretty fun, right? We are too much into BCI. Like we have some significant steps in BCI. We have already made some significant steps in BCI. Great. Let's move ahead. So if we can communicate between two brains, then why cannot multi-brains? So what about BrainNet, multi-person BrainNet? We can even make a social network out of brains. You can think of this that every brain has a co-processor attached and there are multiple brains they are communicating. You can think of a brain book instead of Facebook. So that would be something we can expect in the next 10 to 20 years. Moving ahead. So by now, I think you guys have started realizing that what could be the potential of this technology. Like it can be a revolution in medical science. It can be revolution in education and learning. It it a totally new domain and scope for entertainment, virtual gaming, and virtual reality has arisen due to this BCI. Uh, we can also in medical science it could be used for restoration of sensory, motor, cognitive function. A person who has lost his brain, certain brain functions, injury in spinal cord. So we can make those people life better using this BCI technology other than other stuffs. Moving ahead. Now, even though the technology is very futuristic, with it brings along with it some ethical and moral concerns. There can be concerns like health and safety. We can get into a totally new debate, like who get to use the device. It is again the rich, those who get to use this technology, or will we have some scheme or subsidizing policy that will make it available to the lower strata of the society also. Something you can think about brain trapping, brain washing. Like viruses can be directly sent into your brain. The complete data of your brain can be erased. There also social justice problems may arise. What about giving this to the prisoners in the jail? How we are gonna make rules for that? So we have to look a lot into that. But should we, even after having so many ethical and moral concerns, should we stop working on this technology? I like to talk about the legend of Thomas and Thought. When the invention of writing was taking place, Thomas told to Thought that by the neglect of memory will produce forgetfulness. Like Thomas was not happy that we are inventing writing because it will lead to people being forgetful. But I think writing has been a good invention, right? We all know that. So that's thing is, I think we can wrap it up by now. So this was, thank you. This was Ankit Agarwal from BrainNet University. That's it.